In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths Mechanics paper 4.2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts if you need to. If you're looking for a different question from this paper or a different paper entirely, check out the description below. You should be able to find a playlist there or have a look around on my channel. Okay, let's get into the maths. In question 2, we're told about two particles, P and Q. We're given their masses and we're told they have to move in a straight line, the same straight line. So let me draw that here. We have a particle P and a particle Q. Let's put P here and Q here. Like I said, that we're told their masses. Let me write them in. It's 0.2 is kg and 0.1 kg. We're then also told that P is projected towards Q at 5 meters per second. So this guy is sent this way at, let's write it in here, 5 meters per second. At the same time, at the same instant, Q is projected away from P. So we'll send him that way. Again, you could have drawn this the opposite. It's just they would have been sent different ways. Would have made no difference to your answer. So they're sent this direction at 2 meters per second. When P collides with Q, because it will, it's going faster, it's going to catch up and collide with it. They coalesce. That means they come together. So let's draw the next stage. When they meet, these two are actually going to coalesce into one object. I can straight away write down its mass, 0.3 kg. The speed will be a little more difficult to get, and we'll need that for the answer. The question they actually ask is find the kinetic energy lost during this collision. Okay, so this is one of those difficult questions well, it's not that difficult, the maths, but it's difficult to know where to start. They haven't given you too much hints on where to start. The fact that they said kinetic energy lost in collision, we definitely want to look at conservation of energy. So that's definitely something we should look at. And hopefully, once you start thinking conservation of energy, I often think conservation of momentum as well. They're not that related. Because we have everything we need here for conservation of momentum. So let's do both of those. Let's do a before, B, and an after. And this is for momentum. Before we have its mass of P multiplied by its speed, that's momentum. Plus we have the mass of Q multiplied by its speed. That's all the momentum in the system before these two balls hit. Actually, I should put A over here, I suppose, after over here. So that's before, that's the total momentum. We can do this out. This is 1 plus 0.2, which is equal 1.2. That's the total momentum in the system. Now, after the collision, we don't know, except we know the answer is this, because there's conservation of momentum. So after we have a 0.3 mass multiplied by some speed v, but we do know that this is equal 1.2. So with conservation of momentum, we can actually solve this speed. Rearrange this, we get v is equal to 1.2 divided by 0.3, which goes in 4 times. This speed up here, this guy, this object, this coalesced object, must be moving this way with a speed of 4 meters per second. I often like to think, does this pass my smell test? Does it make sense? I think we have a big object here, twice the size of this one, going fast, going at 5, and it hits into this. It would slow down, so I would expect my answer to be less than 5. But it shouldn't slow down too much because this guy was also moving that. He's a lot bigger. 4 sounds about right. That sounds reasonable to me. If you got an answer here minus something, you should be worried. Why would it go backwards? If you got an answer bigger than 5, I'd be worried too. So 4 seems about right. So that was with conservation of momentum. Took up way too much room. Actually, you know what? Let me rub these out and we'll do conservation of energy. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
So conservation of energy tells us that the kinetic energy, that's half the mass. This is half mv squared. Half the mass multiplied by its velocity squared is P's kinetic energy. So Q's kinetic energy, we'll add that together to get the total kinetic energy, is a half 0.1 times 2 squared. That's all the kinetic energy in this system before. Afterwards, we have a half 0.3, that's its mass, multiplied by 4 squared. That's the kinetic energy in this system. We can work both of these out and we'll notice that they're missing something because they told us already there was kinetic energy lost during the collision through noise or heat or whatever. And so there's some number here missing that we should take away. That's one way to think of it. And let me just do these numbers out first. I have it here actually. It's 2.7, if I'm reading my writing correct, 2.7 joules over here. And afterwards, it's 2.4 joules. That's the kinetic energy before, the kinetic energy after. So something did get lost in it. And that's what they asked us. So the answer is simply, 0.3. To think of it as well, you could write 0.3 joules equals. That's the conservation of energy once we take this guy into account. Anyway, the answer they're looking for is simply 0.3 joules. That's the kinetic energy lost when these two masses particles coalesce. Okay, that's it for question 2. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.